Okay, so a survey of Alberta students was used to estimate the percentage of students who participate in school and non-school athletics, as well as the percentage who do not participate in any athletics. The results of the survey are shown in the Venn diagram. 15% only school, 38% both school and non-school, 26% only non-school, 21% neither. The odds in favor of randomly selecting an Alberta student who participates in school athletics. Okay, so when they say odds in favor, what they mean is your likely outcomes compared to your favorable outcomes compared to your unfavorable outcomes. So your favorable outcomes is 15% plus 38 because they ask for participates in school athletics. Well, there are 15% plus 38%, being 53% of students participate in school athletics. And how many odds in favor of randomly an Alberta student? So they're just asking for, out of any Alberta student, if I randomly picked one, what are the odds that that student participates in school athletics? Well, it's 53% compared to the unfavorable outcomes, which is 26 plus 21, which is 47. So the answer is D, 53 to 47. Okay. Probability and odds of adjusting the radio while driving in 3 Canadian provinces. If the provinces listed are arranged in order from the lowest probability to the highest probability, the order will be. Okay, so who has the lowest probability? Let's figure this out. In BC, the odds in favor of adjusting the radio are 14 to 11. So what that means is you go 14 divided by 25, and that gives you 56%. In Ontario, the probability of driver adjusting the radio is 61%. So far, 56, 61. What about Alberta? Alberta, it says the odds against the driver adjusting the radio are 8 to 17. So all that means is the odds in favor is just reversed, 17 to 8, which means 17 divided by 25 is 68%. So we have 56 for BC, 61 for Ontario, and 68 for Alberta. So the correct answer, it asks for lowest probability to highest probability. So that's BC at 56, Ontario at 61, and Alberta at 68. BC, Ontario, Alberta. BC, Ontario, Alberta. The answer is C. There are 10 black, 12 red, 14 yellow, 9 green, 8 orange, and 11 purple candies in a particular package of candy. If one candy is randomly selected, then the probability to the nearest hundredth that it's a red or a black candy. So this is straightforward. All you do is you take red candies and black candies, which is 10 plus 12, and then you divide by the total number of candies. So what's the total number? 10 plus 12 plus 14 plus 9 plus 8 plus 11. 64. There's 10 black and 12 red, so that's 22 candies that we're looking for divided by 64 total candies. So 22 divided by 64. Probability to the nearest hundredth is 0.34. 0.34. A child has a box containing 8 toy cars and 6 toy trucks. He reaches in and randomly selects 2 toys, one after another, without replacement. Which of the following expressions could be used to determine the probability that the 2 toys selected are both toy cars? Well, it says without replacement, so once the first selection is made, Once that first selection is made, the toy is not returned. To the box. So you're going to select one toy, and you're looking for a toy car. So the first one is 8 divided by 14 chance. And then you're left with a situation where there's 13 toys remaining, and 7 of them are toy cars. So the probability of the next one is 7 over 13. So it's 8 over 14 times 7 over 13, which is B. An automobile association collected data, probability occurring different time periods of the day, and separate data, separate meaning independent data, on the probability of an accident occurring in each month of the year. So one's for the time of day and one's for the month of the year. The data shown in the 2 tables below. So there's a whole bunch of data here. What we're being asked is, assuming that these are independent events, the probability to the nearest hundredth that a randomly selected accident will occur in the time period 1500 to 1850 in December is. Okay, so first thing to note is that these are independent events, which means anytime 2 events are independent, you can simply multiply their probabilities. Since the variables are independent, simply multiply the applicable probabilities. Okay. So it asks for 1500 to 1859 in December. So 1500 to 1859, the probability is 0.286. And in December, it's 0.134. So take the 0.286 and the 0.134 and multiply them to give you 0.04. Answer is 0.04.